Making metal powders usually involves melting the material first. In a process like atomization, molten metal is passed through a stream of water or a gas like argon so that it solidifies into spherical particles, which then need to be sieved and divided into different sizes. That melting can take a lot of energy, and you almost always end up with some powder that's too big and some that's too small to be sold. So you're producing a little bit more than you need. I'm Stephanie Hendrickson with Additive Manufacturing Media, and I recently learned about a company that is manufacturing metal powders with no melting whatsoever. The company is called Powder Works, or MPW, and I visited their facility in Pittsburgh, Pennsylvania, located at Neighborhood 91. Powder Works has developed a method for turning solid metal into powder without a phase change. In their direct powder process, the material stays solid throughout and mechanically is turned into metal powder. To do this, they use what is essentially a highly controlled lathe. Solid, off-the-shelf Barstock goes in, and the machine very precisely chips away material using a proprietary cutting tool. There is waste that's generated with this process. There are material cores and chips that come off, which can be recycled, but the key is that almost all the powder that is produced is very similar in size, so you're not ending up with a lot of unusable or out-of-size powder at the end. Powder made in this way does look and behave a little bit differently, namely because it is angular rather than spherical. In some 3D printing processes, this doesn't seem to matter a whole lot. Powder Works provides material, for instance, to its neighbor at Neighborhood 91, Hammer Industries. Hammer uses a cold spray process, a machine from Speed 3D, to produce metal parts, often as casting replacements. And they're finding that this angular powder can be used without any difficulty. It may also change the behavior of certain other types of processes. Powder Works has reason to believe that this angular powder in a material like copper could actually be easier to process with laser powder bed fusion. Of course, in cases where roundness is really important, there are ways to further process this material. MPW has partnered with 6K Additive, another Pennsylvania-based company that has developed a process for spheroidizing metal particles called Unimelt, and that is compatible with this angular material as well. So, what are the benefits to being able to mechanically produce metal powders like this? One, it's potentially a cost savings, especially if you're dealing with an unusual alloy or very small amounts of material. If you're not producing tons and tons of material, gas atomization may not be worth it. It could be more economical to choose a milling process like this one. Second, it could be more sustainable. As a recent study from the Additive Manufacturing Green Trade Association suggests, milling processes like this can actually have a smaller carbon footprint compared to other types of powder production. There may also be benefits specific to this particular solution from Powder Works. The machine that they have designed and manufacture is small enough to be placed at an additive manufacturing facility or deployed out in an expeditionary situation to manufacture powder on location. That is important because it helps to alleviate a lot of the challenges of powder handling. Instead of storing metal powder that has to be protected from things like static and humidity, you can store and ship solid Barstock, which is widely available in a whole range of different alloys and materials. If you want to learn more about Powder Works or anything else mentioned in this video, see the links in the video description below. And if you're interested in more AM materials, technology, and applications, subscribe to Additive Manufacturing Media. We'll put a link in the show notes as well. Thanks for watching.